Quando vuoi.
See. Go. Hi everyone, so thank you for being with us today for this presentation. So we're going to talk about control center. So my name is Fabien Rigaud, I'm in charge of the marketing, and I will explain you how we deal with the renewable energy control center. So this presentation will be divided in 3 parts. First one is the short overview of the company. Of course, you know who we are and what we do. Then we will see the business challenges and the figures about what is the control center for renewable energy. And then we'll have a look on the kind of technical overview of what we did for this customer. Okay? So of course, feel free to stop me if you have any question. So just to introduce Pcvue Solutions, so we are a company dealing with software solution. What we do basically is to collect data, so we get data from the field. Then we enhance the data, so we treat the data. Then we create the graphical interface, so what we call mimics on the SCADA system. Then of course we store the data inside the database. And then we share the data with any other system, any other platform. We have 40 years of experience. We started with the industry, but we moved to the building and the energy and transportation and many businesses. We are a global player, so we are an international company with the headquarters in France, but we have office worldwide just to address directly our customers with technical support, by the way, locally. Some of our customers, just for you to have a look on the company who are working or using our software solution. So it comes from let's say the energy, like we're going to talk about IBERDROLA today. We deal with many kind of customers in many areas. So what is Pcvue? Pcvue is a software platform, and the first step is to create the configuration of the systems. And we usually say that we have no code, so no need to script the system, it's just parameters and you develop the application. So the development is done with the no-code systems. And then we have the connection, so we deploy the system and we get data from the field with the connectivity. Then we monitor and control the data, so we create the graphical parts. We will see some example after. So then we have the alarm and event management. So as the system collect data, we have alarms and events that we need to treat and filter. We'll see what they do inside the IBERDROLA project. Then we need to enhance the data, as we said before, some filtering, some artificial intelligence inside the system. And then we process the data. So all this is a Pcvue platform. So what is our value proposition in Pcvue in general? So we say basically that we have a modular offer. So for each kind of application, we can address different kind of systems, small systems, big systems. We can address several kind of projects. So we can reuse the product. Once you are trained on the product, you can reuse it and deploy the product on any installation you want. So it decreases the investments for the training. Of course, we have something which is called object orientation. It's well known by the software guys, so it just decreased the development cost thanks to this object orientation based. And we'll see in the renewable energy that it's very interesting because we have a lot of copy paste that we can do because we control many systems which are quite similar. We are vendor agnostic, so we do only software. We do not provide any hardware. But we need to be able to be connected to any kind of hardware. So we communicate, we have 180 drivers, so way to connect the software system to any device. So it's like Modbus, a well-known system, or BACnet or whatever. So we have hundreds of drivers which are built in the product. So no need to use some gateway like OPC or things like that. Okay? Of course, it's an open system, so we have SDK, we have web services, we have a REST API, many things to connect any change data to other systems. So let's go more deeply inside the renewable energy control center. What are the challenges? So they need to control in real time hundreds of assets, spread assets worldwide, from the local control system, locally in the wind farm, but also from the control center. And obviously they have a lot of data, so they need to filter the data at each level. And for sure, having something which is available 24 hours, 7 days a week. Then they need to connect to any players. When you are talking about players, it could be any wind turbine provider, any PV provider, any hydro system. So they need to collect data and be able to be connected to any systems available on the field. And then with all the data, we need to collect it, make aggregation, and provide to the user the right data at the right moment to decide and take a decision about what he needs to do. And of course, there is something important, is the connection with the dispatching center. So the data we are collecting from the field, we need to exchange with the dispatching center, and we will see after which kind of driver we use for this kind of stuff. So this is the control room from IBERDROLA. So thank you, IBERDROLA, for giving us the authorization to communicate on this project. This is the control center from Toledo in Spain. The picture is quite as few years, but who is IBERDROLA? So it's the largest provider of wind energy in the world. The second one in North America. And I took few information from the website just this afternoon, just to make you aware about the money they put on the table for this kind of business. So 44 billion euro will be channeled for the renewable energy area, so it's a lot of money. And regarding the energy, we forecast to produce 44 gigawatts of renewable energy in 2 years and 60 in 2025. So it's a huge project. So we deal with several control centers with IBERDROLA, not only the one in Spain. So we deal with the first one in Spain. We started almost 20 years ago with IBERDROLA, and it was the control center in Toledo. From this control center, we were controlling all the wind farms worldwide, and now we control many in Europe. And it's 270 wind farms, 6,000 turbines worldwide, controlled by Pcvue. And it comes, this is really impressive, amazing, 2.5 million tags on the control center. So it's a quite big control center with a lot of data. Then we did the second one in the US with the Avangrid company. It's a part of IBERDROLA. So same story, we control all the wind farms. We control also PV plants there. And they produce around 9 gigawatts of energy, and 3.4 million tags are collected on the field. So a lot of data there. And we have also a control center in Scotland with Scottish Power, and we have one in Brazil with Neoenergia, and obviously some disaster recovery, which are everywhere in each country. If there is any issue on the control center, there are some disaster recovery for each system. And in total, it's 37 gigawatts of photovoltaic. There is also offshore wind, so they deal with in Baltic area we have offshore winds, and also in the US, I guess, if I remember, onshore wind, hydroelectric. We create the new control center of hydro business in Spain, and also what we call BESS, battery energy storage systems. So to store the energy in the battery to release it after during the day when the energy, the wind or the solar energy is not there. So what are the business challenges of IBERDROLA? Of course, monitor and control wind turbines which are installed in the world, so across several time zones, several areas. So they need a good network. They use satellites and so on. So we are not dealing with this part. So they're in charge of collecting data and connecting all the wind farms up to the control center. Of course, they have a high growth rate of expansion. So they add wind farms every day, almost every day. They add new wind turbines, a lot of data which are generated every day. So they need to manage a huge amount of data. We saw it just before, 2.5 million in the control center in Portland, in the US. So it's a lot of data. So regarding the operational constraints, so they need to display the variable of a given subsystem in a structured way. That means that they decided to say, okay, even if I have several providers of wind turbine, I need to create something which is clear for everyone. Someone in the control center who is looking for the data for the wind turbine must understand quickly what is the issue from the wind turbine. So even if the provider of the wind turbine is different, they create a kind of structured database to understand clearly and being able to duplicate the content quickly. They need to perform alarm management, 1 million alarms per day. Sometimes we have a lot of alarms. So imagine a user in front of the control center just trying to understand what's happened. They need a very flexible system to filter, make analysis of the alarms to take the right decision. Of course, we store the data. We have a short-term and long-term storage of the data with Pcvue and also with Oracle. And they use also an historian software and Pi software. And of course, they do dashboarding or reporting on the system. So regarding the technical features, so we have 3 levels. So the first level is the wind farm or the local level. So PV, wind farms, hydro. So we get data from there. And then we have the control center. So this is the level 2. So we centralize data there. We get all the data from the field and we put it inside the control center. We monitor and control. We saw the picture before with the big control room where guys can see the country and then zoom in, zoom out to see the data. They store the data there. Of course, we run on virtual machine. It's not a classical virtual machine. It could be also on the cloud. So we deal with a VM there. And then we collect the data which are collected are sent to the dispatching center. There is an exchange there to send information in that way and get data from the dispatching center. Okay. So basically what we have there, we use inside Pcvue all the drivers which are there to collect data to the system locally. So we have 61850, 104, DNP3, 101, and also OPC, Modbus, etc., etc. So we use several drivers to collect data from the field and get the data locally, and then we send through the wide area network to the level 2 and then the level 3. So in the control center we have from 40 to 60 redundant servers, depending on the control center. So this is the VM that are running, getting data from the field. So we have association of redundant servers, so we need really stability and high availability of the system. Each server just get data from a dedicated area, so we can make maintenance on the system and see, for example, those 2 servers will have a look on Spain only, 1 on France, etc., from the control center. And we have a graphical interface, feed clients, which are from Pcvue, which are connected to any cluster locally. So those machines are taking care about millions of data that are collecting from every redundant server. Okay, and each server is dealing with 300,000 variables, more or less. It depends on the area, but a lot of data are coming from the field. And we push data also on the Oracle database. And we have also web clients to have a control from using HTML5 on the web. So in the level 3, we use the ICCP, Inter-Control Center Protocol, to exchange data. It's called also TASE2, to exchange data from the control center to the dispatching center. So at the end, this is the architecture. You can see all the levels there with the product which are used, and the servers there on the control center, dispatching center, and the local system. So this is an example of screenshot that they are using. So they decided to go on something very simple, but a lot of, let's say, copy-paste, like I said before, just to be able to create quickly the mimics. In fact, inside Pcvue, you can generate automatically the mimics from outside. So they created some tools to generate the mimic quickly, because as I told you, we have a high growth new data every day, wind turbines. So this is another example of the wind turbines. The graphical part is more or less always the same. They just navigate through the country and then the wind farm, and then they select the good wind turbine. So the project results. So all the IBERDROLA wind farms are remotely connected, so we get the data from every wind farms. The Pcvue solution decreased the downtime of the system. The availability is quite good. They are able to control their system all the day long. Now Pcvue is really the system that become the central SCADA for IBERDROLA group. So Scottish Power in Scotland, Avangrid in the US, and Neo Energy in Brazil. So they use really Pcvue because they really know well the product now, and they created some very specific functionality around the product. So the success factors, of course, it's robust because it needs to run 24 hours, 7 days a week, managing a lot of data. It's scalable because we can put the Pcvue in the local wind farm, but also in the control center. So they use the same product for both. And just one interesting information, they gave me this information. They use 4 hours to create to integrate a new wind turbine. So creating the database, the connection, the graphical, the archiving, etc., etc. In 4 hours, they are able to create add any wind turbine, so it's quite interesting. And the product is quite open for them, so they can imagine to share any data they have from the control center to any other system by using all the functionality we have inside Pcvue. So that's all. I hope it was interesting for you to understand better what we did with a customer, and we're still going on. So if you have any question, feel free to ask.